All right, let's start. So, so the first topic, compression. All that means is, when you make your, feel free to stop me or just use the function to raise your hand if you want me to stop. But we've got an hour together. So, compression, all that means is, when you make a file smaller. Let me turn my camera on. All that means is you make a file smaller. And there are two methods of compression. So there's lossy and then there's lossless. So you just need to know for your exam on Friday the difference between the two and when one would be more suitable than the other. So let's start off with, we can just respond in the chat. So let's start off with a few questions. See if we remember, we've already done the first one. So what are the two methods of compression? That is lossy and lossless. Now let's look at the difference. Which method of compression restores the file back to its original? You could just respond in the chat if you want. Correct, yeah, lossless, correct. And then which method of compression identifies repeated patterns? Yeah, correct, so it's lossless. And then which method permanently removes data? Lossy, yeah, correct, excellent, good. So one, lossless is when you send the file, it goes back to its original. With lossless, with lossy, that removes the data permanently. So lossy makes the file smaller, but then the file cannot be returned to its original. All right, let's have a look at this now. This is just a description of the two. So lossy compression removes the parts that we cannot hear or see easily, permanently reducing the file size. Lossless compression leaves out repeated data and the file is restored to original form. If I had some program code that I wrote in Python, okay, and I wanted to send this, but it was very big, so I wanted to compress it, would I use lossy or would I use lossless, do you think? For a program code, what do you think, lossy or lossless?
Is it lossy?
Lossy. Why? What made you say lossy?
Like if there's unnecessary parts, but maybe if some things are removed, it won't function the same way.
Correct, exactly. There you go, Judy. So if we used lossy and we moved some parts permanently, then some parts of the program code would not function correctly. Because imagine the syntax would be incorrect when we send it. So we would use lossless so that nothing is removed permanently. It's restored to its original form. Because with program code, if anything's removed, then it'll affect the syntax, which means the program won't work. What about streaming a movie, a large like HD movie? If I was streaming that, what type of compression would that be, do you think? Yeah, lossy. Because look at that, it removes the parts that we cannot hear or see easily. So it won't affect us when we're watching the film. We won't be able to notice any difference in the quality of the film, but it'll make the file small enough so that it can be streamed very quickly. All right, let's look at a question now. Let me just open up a question and then we'll answer this together. So sorry guys. All right. Can you guys see the question?
Yeah.
All right, awesome. Let's answer this now. So let me just edit the document. I need to edit and then add some text. So the following text is stored as a text file, okay? And then it's just this: she sells seashells on the seashore. The shells that she sells are seashells, I am sure. So what if for 5 marks, it says explain how lossless compression would compress this file? So how would it compress this file? So what could we say, do you think, for 5 marks?
You can start with it uses a compression algorithm.
Excellent, yeah. So a compression algorithm is used. That's number 1. Okay, so that's 1 mark. And this, go on, Ali.
Say like it searches for like repeated words and indexes or something.
Good, so that's actually 2 marks. So we'll split that. Searches for repeated words. in the text file. So if we look at this, something like, I don't know, shells is repeated 3 times. So it will search for repeated data. And what did you say that word that you use, what does it do?
Index.
Good. The compression algorithm creates an index for the repeated data items. Look, we've got 3 marks already out of 5. We just need 2 more marks. You know, a key feature that makes it different from lossy, what would that be?
It can be returned to the original.
Good. So we could say no data is permanently removed, and it can be restored to its original file. All right, good. We've got 4 marks, guys. We need 1 more mark for this question, for this response.
Can we say they put the words into a table?
Yeah. So we can say,
And then like notes the position that they are in.
good. So the table one would be the same as creates an index for repeated data items. But then you said, what was the second point you said, Judy?
It notes the positions they are stored in.
Good. We would say the position of repeated items is noted, and we can say the number of times that appears will be stored. Okay. All right, so that's the 5 marks there. Compression algorithms used, searches for the repeated words in the text file. The compression algorithm creates an index for repeated data items. No data is permanently removed and it can be restored to its original file. The position of repeated items is noted, and the number of times each word appears will be stored. You know, why couldn't we use, for this following text, why couldn't we use lossy compression?
Because like it wouldn't be the same. It would take out them permanently, so it wouldn't be the same sentence.
Good. The sentence won't make sense because it will remove data permanently. So lossy would not be a suitable method of compression. Excellent. Good. Nice. So that's compression. Let's now move on to CPU, which is it's a bit of a tricky topic in the exam. But if we have a look at this, so if you have a look, I'm just presenting my screen. The CPU can be split up. You know, it's very technical. It's quite a lot that you have to remember. But if you break it down into 4 parts, so the cycle, the buses, the registers, and what affects the performance of a CPU, if you break it up into those 4 parts, then it'll make responding to the questions much, much easier. Okay? So we know the cycle of the CPU. It takes 3 steps. It goes fetch, decode, execute, and it does this thousands or millions of times per second. So that's what the CPU does. It fetches an instruction, it decodes it, it carries it out, and it does that many, many times. But the architecture of a CPU has some buses and has some registers. In the chat, please, just write down the names of the 3 buses. The 3 buses. Control, yeah, is 1. Serial bus. Serial, not serial, Judy. It's not serial. You're thinking data transmission, which can do, which is a universal serial bus. But it's not a bus associated with the CPU. Control, there's 2 more. One begins with D and one begins with A. Address, good. That's the second one. So we've got the address, we've got the control, 1 more. And the data, good. So the address, control, and data bus. Excellent. All right. Now, so that's the 3 buses. So all a bus is a wire used to transmit data associated with the CPU. Okay. Now, what other? There are 5 registers. So the registers is like memory that the CPU uses to store the data. Okay. So yet CIR is 1. So we've got 1. So we'll say 1 CIR. Good. MAR 2. Memory address register. ALU. Do you know there's 5 registers, Judy, and the ALU is something called the arithmetic logic unit. That's where the calculation is carried out. Technically, it's not a register, but it's part of the CPU. So yet 3 MBR, yet 4 the accumulator. So we need 1 more. So we've got CIR, MAR, MDR, ACC. The last one, PC, there you go, excellent. So number 5 is the program counter, which counts the number of instructions, okay? Let's have a look and see what a question would look like then in this area. So let's have a look and we can answer this together. I think we've done this question maybe in the mock in our but I've got 2 CPU questions. We did this question maybe in our mock. So let's have a look at this question. So 6 components of a computer are given. Some are parts of the CPU of the von Neumann model for a computer system. Tick to show if each component is a CPU component or is not a CPU component. So let's have a look. The ALU, is that part of the CPU?
Yeah.
Yep, it is. Okay, nice. Hard disk drive, is that part of the CPU or not? What do you guys reckon? HDD.
No, it's not.
It's not, yeah. It's not a bus, it's not a register. It's not used in the fetch, decode, execute cycle. It's another component, so it's not part of the CPU. All right, excellent. MAR?
Yes.
Yeah. And that's an example of what?
Register.
Register, excellent. Yeah, good. The RAM. Is that a part of the CPU or is that a different component? Okay, the CPU uses it. Sorry, go on.
Is it not a part of the CPU?
Yeah, it's not part. The CPU uses the RAM. That's where it fetches the instructions from, but it's not a component of the CPU. The RAM is a separate component. SSD, again, is another memory. Would that be CPU or not?
It's not.
Not yet. So it's not. Can you guys see the marks that I'm putting on, by the way?
Yeah.
Okay. All right. And then the last one, control unit. The CPU or not?
It is.
It is, yeah. It's just not a register. It's not a bus, but it's part of the CPU. So there you go. In an exam, a question like this, nice, I mean, generally speaking, a nice, easy 6 marks. Fingers crossed we get some questions like this on Friday. All right. This one's actually another topic. So we'll come back to this question, actually, the sensors. Let's try another CPU topic. So this is about compression, which we've done. All right. So this is about the von Neumann here. Let me just edit the document. Yeah. So a computer is designed using the von Neumann model for a computer system. The computer has a CPU. Data is fetched from primary storage into the CPU to be processed. State the name of the primary storage from where data is fetched. Where is it? Where does the data initially come from? It's not part of the CPU, but it's another component.
The RAM.
RAM, yeah, perfect. So let me just add. So RAM. What does the acronym stand for, Ali? Do you remember?
Random access memory.
Yeah, random access memory. Excellent. RAM actually would suffice in the mark scheme. That would be fine if you just wrote RAM. All right, the CPU performs a cycle to process data. Fetch is the first stage in this cycle. State the name of the second and third stages.
Decode and execute.
Good. Decode and execute. Yeah. Decode and then execute. All right. So decode, fetch, decode, and execute. Last question now. Identify two components within the CPU that are used in the fetch stage of the cycle. So what components there's, in fact, for this question, there's an option of, let's say 5, maybe 6 that we could say.
MAR and PC.
Good, yeah. So MAR, PC. There's loads more as well. We could say any of the buses. So what are any of the buses? Give me a name of one of the buses.
Address bus.
Address, yeah. Say control bus, and then the data. Also, sorry, I just put this. We only need 2 marks. We could also have said the MDR, so the memory data register, which is also used. So any of those components. So there's 1, 2, 3, 4, 5, 6 that we could have got for the 2 marks. All right, nice. This question, right, as the hardest it will get is for you. Do you know when it asks you to, describe the cycle? They won't ask you. I've never seen a question where it tells you to write all the steps. Normally, what they do is they give you the steps, and then you have to put them in the correct order. Okay, so that's probably go on, Judy.
That question you just did, was it only in the fetch stage where all these are used, or is it in the whole process?
Sorry, I can't hear you very well. Go on, say that again.
In that question that we just did, are these only used in the fetch stage or also in the decode and execute?
They're also used in the decode and execute. These components, they're also used, but some of them, for example, the address bus is only in the fetch stage because it has to fetch it from the correct address. It's not used in the decode. So in the decode, the MAR would still be used. The PC would not be incremented. That would be incremented in the fetch stage. The MDR would be used. The control and the data bus would be used. And then in the execute stage, that would use, in the decode as well, it would use the current instruction register and the accumulator. In the execute stage, it'd use the control bus, that's used in all 3 stages. The data bus, that's used in all 3 stages. The MAR is fetched already, so it's not used. The MDR is used, and then the ALU, which is the arithmetic logic unit, when it carries out the instruction. Yeah. All right, guys. Just, we're going to take a 2-minute break. Just a 2-minute break. I'm just going to grab some water, and then we'll come back in 2 minutes, okay? And then we'll move on to the next topic. But if we have a look, so far we've done compression and then CPU, okay? So just 2 minutes, and then we'll come back. All right, guys, we'll restart if you guys are ready. So the next topic we're going to do is automated systems, okay? This topic is commonly like the very long extended question in an exam, anything from 6 to 8 marks. So all this is, you know, when it uses, when the system uses something like sensors and a microprocessor to allow a system to run without human intervention. For example, a greenhouse, okay? A greenhouse would use a temperature sensor and it would use motors to allow the fruits and vegetables to grow in the optimum temperature with minimal human intervention. It's automated, it's automatic without the need for any humans. And in an exam, this is likely to be the 8 mark or 6 to 8 mark question or response. And you basically have to describe the process. So we're going to look at a question in a minute. But before we look at a question, let's have a look at this. So this is generally what happens in an automated system. A sensor is activated. The sensor then sends the signal to a microprocessor. A microprocessor is just a small processor. So its job is to process the instructions. The signal, because you know when we take a reading using a sensor, the reading is in analog. It's in various states. But in order for a computer to carry out an instruction, it must be converted to digital, which is like binary, one of two states. So the signal is converted to digital using an ADC. Then the microprocessor would analyze the data. So we're going to look at an example. And if the data is outside an acceptable range, then something happens. So for example, it could be too cold, it could be too hot. There could be too many people, there could be too few people, and so on. So let's apply this to a greenhouse. So a greenhouse, what would happen is a temperature sensor takes some readings of the temperature every so often. It might be every minute, it might be every half an hour, it might even be every 10 seconds. The temperature reading is then sent to the processor. It's converted to binary. So the initial reading is analog. It might say it's 25 degrees inside the greenhouse. 25 is an analog number. So it needs to be converted to binary. The microprocessor, and then what this automated system would have is a range of optimum temperature. So for example, optimum in this greenhouse is between 20 and 25 degrees. It would take the reading, it would compare it with the optimum temperature, and if it falls out the optimum temperature, some action would be carried out. So an action could be if it's over the optimum temperature, then a motor would open a window. If it's below the optimum temperature, then the motor might close the window and switch on, I don't know, some heating or some lights. And it will do this process continuously so that the fruits and the vegetables and the flowers, they can grow in the optimum conditions. All right, so let's have a look at a question now and see what this will look like. So let me just change the presentation. All right, so here's the question, okay? So let me just edit the PDF. And this question is, I believe, let's have a look, I think 8 marks maybe? 8 marks, which is significant. Imagine you get a question like this on Friday in the exam. You might not, I'm not sure. But 8 marks would account for more than 10% of that paper, because the paper is 75 marks. So that would count for more, which is significant. So let's have a look at this. Jamelia has a greenhouse that she uses to grow fruit and vegetables. She needs to make sure the temperature in the greenhouse stays between 25 degrees and 30 degrees inclusive. Inclusive means it can be 25 and 30 and anything in between. A system that has a temperature sensor and a microprocessor is used to maintain the temperature in the greenhouse. The system will open a window and turn a heater off if it gets too hot, close a window and turn a heater on if it gets too cold. Describe how the system uses the temperature sensor and the microprocessor to maintain the temperature in the greenhouse. So let's have a look. What would be the first thing that is carried out? What is the very first thing this does in this automated system?
Do we say the sensor is activated and then it's
Yeah.
at the microprocessor?
Good, the sensor is activated, but Judy, if we were to apply it to this question,
The temperature sensor.
good, a temperature sensor. So a temperature sensor, if we say activated, then what would be something else? What does a temperature sensor do? It takes a
Reading.
It takes a reading. Good. So that's one mark. That's the first mark. A temperature sensor takes a reading. What happens next, do we think? When it takes the
Sensor.
reading. Say that again.
The sensor sends data to the microprocessor.
Good. Sensor sends the data to the microprocessor. Good. All right. So now the microprocessor, the reading was in analog. The microprocessor or the computer, in order to carry out an action, only understands digital. So what has to happen to that data?
It's going to be converted to digital binary using ADC.
Good. Data is converted to digital using an ADC, which is that just stands for analog to digital converter. We don't need to know any more than that. We've already got 3 marks, guys. We need another 5 marks. So when it's got the reading, what does it do with the reading?
It checks
Is it-
whether it's between 25 and 30.
Good, because here it says the greenhouse has to stay between 25 and 30 degrees. So what checks it though?
Microprocessor.
Yeah, the microprocessor checks if the reading is between, we can say 25 and 30 degrees, okay? Or we can say, another thing we could also say is compares with stored values. And what is the stored value? The stored value is between 25 and 30. Good, excellent. All right, we've got 4 marks. Now, what happens if it's below 25 degrees?
If it's below,
Yeah.
it closes the window and turns on the heater.
Good, good. If the data is below 25, then it closes a window and turns a heater on because it tells us that it's too cold. So if it's below 25, that means it's too cold. So it will be this bullet point. Good. If the data is above 30, what happens then? What does the other bullet point say if it's too hot? So if it's above 30 degrees, it's too hot. What does that mean?
It will open a window and then turn a heater off.
Good. So then it will open a window and turn a heater off. How many marks do we have now? 1, 2, 3, 4, 5, 6. We need 2 more marks to get the full 8 marks. What could we add? The temperature, can it only be below and above? It can also be what?
Including them.
Say that again, Judy, I can't hear you, sorry.
It can also include 25 and 30.
Yeah, it can also include 25 and 30. So if it's 25 or 30, that means it's acceptable, right? So if it is between the limits of, or we could say better word than limits, the range of the stored value, if it's between, is any action taken?
No.
Yeah, no, because it's not too hot, it's not too cold. So we can say no action is taken. All right, that's how many marks? 1, 2, 3, 4, 5, 6, 7. 1 more mark.
You can say the whole process is continuous.
Excellent, yeah. Good stuff, Ali. Whole process is continuous. You know why? If it only did this once, this process once, then it won't be a very effective automated system. But it's going to do this system continuously to make it automated. Okay? So this is the type of question that you could get for something about sensors and automated systems. If we go back to this question here, I don't know if I'm still presenting. No, I'm not. Sorry, guys. So now let's go back to this. We know about the automated systems. Now let's look at sensors. We need to be able to read a scenario like here and then identify a correct sensor. And then it says a different sensor must be used for each scenario. I think we did this in our winter mock, this question. Detecting when a person is approaching an automatic door system. What sensor could I use for this one? What would be a good sensor? So let's list, let me just list loads of sensors.
Does pressure work or no? Oh, it's motion.
Pressure would work. Yeah. Pressure would work. Kareem, you're right. Sorry, I've just seen your response now on the chat on the last question. And that is correct, yeah. Motion, yeah, motion is correct as well. So yeah, we could say either pressure or motion. We'll say motion, okay? All right, and then monitoring the pollution levels in a river. What could we use for that? What kind of sensor could we use? pH, yeah, pH is correct, good. pH, excellent. And then checking if a tropical aquarium is 25 degrees, similar to the one that we've just used. Yeah, perfect temperature. Excellent. And then the last one now is counting the number of cars that cross a bridge. I could say motion, right? Just like the first question, but why would I only get 3 marks and not 4 marks?
Said to use different ones.
Good. Yeah, the question said a different sensor. So we can't use motion again. What could we use that might recognize some cars that are crossing a bridge?
The pressure sensor.
Yeah, pressure. It recognized the weight. Excellent. Good. All right. Now, let's move on. All right, 2 more topics, guys, and 2 more questions, and then we're done. And then you guys can ask any questions that you might have. So let's have a look. Next one is chapter 5, security. So we've got, on the left, we've got 6 threats. And then what we need to do is to try and match them up. Okay, so we've got 6 threats. I'm not even presenting, sorry, guys. Give me a minute. All right. So we've got virus, spyware, DOS attack or DDoS attack, phishing, hacking, and malware. And then on the right, we've got the descriptions. Anyone want to try them? Anyone want to try? Any one of them. Yeah.
Spyware is
Yeah, got spyware. Tell us, go on, Ali.
a malicious software program loaded onto a user's computer without the user's knowledge.
Without the user's knowledge.
Or performs malicious actions.
Say that again. The second last one, is that correct?
Yeah.
A malicious software program loaded onto the user's computer without the user's knowledge and performs malicious actions. That's actually describing another one. You know, if I'm spying on you, Ali, what am I doing?
You're like gaining information.
Exactly. I'm gathering information about you. So technically, it is a malicious software. And yes, it's loaded onto the computer without the user's knowledge, but it doesn't necessarily perform malicious actions, even though spying is malicious, but it's designed to gather information about you.
Yes.
So it's not that. Say that again?
Second one.
Second one, yeah. So software with a malicious behavior that aims to gather information about a person. Good. So just put if you guys can see, I'm just going to put that one like that. All right, good. You know, DDoS attack, what does that mean? DDoS.
Sir, is it when like the web server is attacked?
Yes, yeah.
So it's
Good.
like the last one, I think.
Yeah, and they make it unavailable. Excellent. Yeah, good. So a DDoS attack is, you know, when someone uses a bot, like a program, to send many requests to a server. And a server can sometimes handle thousands of requests at a time, or even millions. But if the DDoS attack sends, say, billions, it's going to cause the server to be overwhelmed, and then it makes the network or the machine unavailable. So that's what a DDoS attack is. All right, phishing, or actually let's try, if I'm hacking, what am I doing?
The third box.
Third one, gaining, excellent, gaining unauthorized access to a computer system. So for example, if I went on, say, logged into Google and I guessed your password, and your password was ABC123, and I guessed it, and I gained access to your Google account, that would be hacking, because you haven't given me authorization to access your system. All right, we got 1, 2, 3 more.
Sir, is phishing the first one?
Phishing, fraudulent attempt to obtain sensitive information. Yes, correct. Yeah. Normally, what medium is phishing used over normally?
Is it email?
Email, correct. Yeah, normally email. Okay. The next one, you know, malware and virus actually is interchangeable, because a virus is an example of malicious software, but malware is the name given to all of them. So ransomware, spyware, viruses, worms. So that would be a collective name for malicious software. And then the last one, a virus, that would be an example of malware, malicious software, loaded onto a user's computer without the user's knowledge and performs malicious actions like deleting their data and so on. All right, good. Let's have a look at this now, guys. These 4 words relate to Chapter 5 security topic. 2 of them are related to each other: secure socket layer and transport layer security. So TLS and SSL. You know, when we see, when we look at a website, and a website has a URL, and the URL has things like, you know, it has HTTP or HTTPS. If it has the S, that means a secure socket layer has been applied to that website. And all that means is anything that we send and receive from this website is encrypted. And encrypted just means it's jumbled up, so it makes sense. So, you know, when we go online and we see the padlock and we see the secure on a website, we can generally trust that website, and we know that all the information sent to and from that website is encrypted. So all SSL is a security protocol that encrypts data whenever we're transmitting, okay? And it uses this digital certificate to say that this website is secure. And then what will happen is when you access the website, if it has an SSL, then it will make sure that the certificate is authentic before any transactions, any information is exchanged. So that's SSL. TLS is just an updated, more secure version of SSL. Okay? So they're the difference. We're going to look at a question in a minute. We're going to look at a question. A firewall is some either software or hardware that examines traffic coming into a network and going out of a network to make sure that it meets some criteria. If it doesn't, then the firewall will block that incoming or outgoing traffic so that it doesn't affect the network. So it's a method of a firewall is a method of protecting against some security threats. Cookies is just a file. Anytime we browse a website, it stores these little text files called cookies that that record the user's behavior on the web. And it's beneficial because it makes the web experience customized for us. Okay? Anyone remember the two different types of cookies? There's two different types. I think we did this in a lesson like a long time ago. One that begins with P and one that begins with S.
Session and persistent.
Yeah, good. So persistent cookies, that means they always stay. Persistent cookies. And what was the other one, sorry, Judy?
Was it session cookies?
Yeah, session cookies. They're cookies that are only while you're browsing the web. So when you close it, then they don't remain. So there's persistent and there's session. Let's have a look at a question now. So this is a 6-mark question. Sorry, let me just present. All right. So it says an art gallery has a website that is used to display and sell art. The gallery uses secure socket layer to provide a secure connection when selling art. Describe the process of SSL and how it provides a secure connection. So for 6 marks. So let me just edit this document. And let's just add some text. How can we describe SSL? What could we say it is? What is SSL? What could we say SSL is? A security, you can say, protocol. Okay, so SSL for 1 mark, we've got already at the 6. It's a 6-mark question. SSL is a security protocol. Okay, what does it do? What is the main purpose of SSL? What does it do to the data?
Does it encrypt the data?
Good, excellent. It encrypts the data. 2 marks. All right. And you know when we use HTTP and we apply SSL, so we can say when we have the hypertext transfer protocol and we apply SSL, it becomes what?
Secure.
Secure, yeah. So it becomes HTTP S, right? So that's what it becomes. Okay, 3 marks. How do we know? We know there's a padlock, but how can an organization, for example, get this SSL protocol? What are they given? What is it?
Does it have to have a certificate?
Good. It uses a digital certificate. Has to have a certificate. Good. Got 4 marks, guys. We need a couple of more marks. You know, how does it know? Because like in real life, you guys, when you do your GCSEs, for example, and you get a grade, you're going to get a certificate. How can someone know if your certificate is is legit, is authentic? What does it have to do? What does it have to do to make sure? What would they do? You probably have to verify, right? It verifies that the certificate is authentic. And if it is, what happens if it is authentic?
The communication between the user and the website is secure.
Good, yeah. And if it is, then the communication begins and is secure. Good. We've got 5 marks. 1, 2, 3, 4, 5. We need 1 more mark for the 4 marks. You know, how do we, how can I put this? The user, what does their web browser do?
Displays.
It displays the padlock, but what does it do? We can say the user's browser makes a. If I wanted to see your certificates, Ali, for example, what would I have to do?
A request.
Good, yeah, makes a request to, we can say, see certificate. Okay, so 6 marks there, SSL. And you know, or we can say, we can add something else as well. We can say TLS is an updated and more secure version of SSL. So it does the same thing. It encrypts data. It has a digital certificate. It verifies that it's authentic, but it's just a more updated and secure version. And that's the 6 marks. Let's have a look at this question now. The art gallery uses a firewall. 6 statements are given about firewalls. We've definitely done this in class. I remember this. We have to decide if the statement is true or false. So firewalls are only available as hardware devices. True or false?
False.
False, yeah. They can also be?
Software.
Software, yeah, correct. Good. Next one. We can say, it says a firewall allows the user to set rules for a network traffic. Sorry. True or false?
True.
True, yeah. That's the whole purpose of a firewall. The whole purpose of a firewall is you set some rules and it monitors incoming and outgoing traffic. Okay, firewalls will automatically stop all malicious software. True or false? True.
Is it true?
True. It's meant to stop malicious, but what if that malicious traffic follows the rules? Will it stop it?
How
Say that again.
could it follow the rules if it's malicious?
Sorry, Judy?
How could it follow the rules if it's malicious?
Because the rules that are set could still accept, for example, communication from Judy's computer. That's a rule. But Judy doesn't know she's sending malicious traffic. So it will accept it because it's coming from Judy's computer, but it's malicious. So it won't stop that malicious software because it abides by the rules. It only stops network traffic that follows the rules. You can't just block all malicious software because it's very vague, it's ambiguous. It doesn't know what all malicious software is. We can say block traffic from an IP address that's not recognized, but it can be a recognized one, i.e. Judy's computer, and then it can still allow it. Okay, so this one is actually false. It's designed to, but it doesn't always stop all malicious traffic. All right, firewalls only examine traffic incoming into a network. True or false?
False.
False, yeah. It's incoming and
Outcoming.
outgoing, yeah, good. Firewalls encrypt all data that is transmitted around a network. True or false? SSL encrypts data. A firewall doesn't encrypt. Firewall is just designed to examine the data. So that will be false. All right, one more. Firewalls can be used to block access to certain websites. True or false?
True.
True, yeah. That's what the school uses. So sometimes you'll notice a game in school is blocked. They use a firewall to block a game. So there you go for 6 marks. All right, excellent. All right, last topic, guys, and then we're done. Are you guys okay to carry on? Because it's gone over the hour. We've got like 10 more minutes. You guys want to carry on? All right. So the last topic now is about memory. Okay, let's have a look at this. So, okay. All right. Let me just present my screen. All right. So memory can be split into, categories. So there's primary, there's secondary, and then there's offline. So primary, how can we describe that? Is memory that is directly accessible by what component?
The CPU.
Yeah, good. Directly accessible by the CPU. Secondary, is that accessible by the CPU?
No.
No. Secondary is memory that is not accessible by the CPU. And then the final one is offline. It's not accessible by the CPU, but it's different to secondary. Why?
It's not connected to the computer, but you can connect it using like something.
Excellent. Yeah, offline is not part of the computer system, but can be connected to the computer. All right, excellent. That's 3, right? So let's look at an example. Give me an example. Can you guys hear a lot of background noise?
Yeah.
Yeah, sorry guys, it's break time in school. Primary. Give me an example of primary storage. There's 2 examples.
Is it RAM and ROM?
Good, RAM and ROM. Okay, they're accessible by the CPU. Secondary, give me something else that's part of the computer system but not directly accessible. Where do you save your work?
A hard disk drive?
Yeah, good. So hard disk drive or just a solid state drive. Good. And then offline is some sort of device that's not part of the computer system, but we can use it as memory and we can attach it. USB, and then finish that one off for me. A USB memory stick. Okay, if you say just USB, you won't get the mark because USB just stands for Universal Serial Bus. You have to say memory stick. So a memory stick is a device that you can connect to the computer system. So it's offline, but it's not part of the computer system. Don't make the mistake in an exam where you think offline means that you're not online, so it doesn't use the internet. That's not what it's referring to as a type of storage. It's referring to a device that you can connect and remove, which is not part of the computer system. All right. Yeah, go on.
Is optical both secondary and offline?
Optical, solid state, and magnetic can be either primary, secondary, or offline. It can be any of them. So, for example, RAM is both solid state and primary. Okay, we can say a CD is both optical and offline, because it's optical is the technology and offline means it's not part of the computer system. A hard disk drive is both secondary and magnetic. See that? So they can, these two, the categories are different. So the red categories and the green categories are not the same. A device can be one from the red and one from the green. It can't be two from the red or two from the green. If that makes sense. It can be one from each. So let's look at another one. A DVD, what categories would that be?
Optical
Yeah, optical and
or secondary?
secondary.
Offline.
Offline, yeah, because it's not part of the computer, a DVD, but you can put it inside a computer. All right, another one, a USB memory stick. What two categories would that be? What two categories would that be? Does it have any moving parts, the USB memory stick?
No.
No, so if it's no moving parts, then that's solid state. And then is it part of the computer system or not?
No.
You attach it, so it's offline. Okay, so there you go, we know the categories. All right, excellent. All right, that is all for memory, guys. Any questions? You guys have any questions about the something you saw in your revision? Any questions? Anything you want clarification on? All right, guys, that exam, paper one, how do you guys feel? Do you feel confident? You feel okay? You still have a little bit of revision to do? Have you guys, by the way, have you got any exams on Thursday or Friday? Friday, actually, anyone who's doing the combined will have ICT as well, I think on Friday. Do you guys have any other exams until before that, before the computer science exam? No, brilliant. Okay, good. So we've got a couple of days of more revision. Obviously, it's only 2 days left till the exam. You just want to focus on paper one. There's no point doing paper two because that's next week. And next week, we're going to have another revision session on paper two. We might even have 2 revision sessions. We'll have one on general paper two, and then we'll have one on the 15-mark question, just answering it. So a whole session on that next week. So last bits of advice for Friday, obviously just focus on paper one revision. Just, what do you call it? Make sure you utilize the full time. You've done so many questions now with the booklet, so many past paper questions. In an exam, a question might throw you off, but you have to try and relate it to a question that you've seen before. And then that will allow you to answer it like properly and in more depth. But don't panic in an exam if the question completely throws you off. Just take your time. The exam is an hour and 45 minutes for 75 marks, which is more than enough time. Your aim should be on Friday is to try your best to bank as many marks as possible so that there's less pressure, you know, next week when you do paper two, which maybe could for some of you will be your strength, but for some of you that might be your area of weakness. So you want to try your best to bank as many marks in paper one. All right. All the best. Good luck. If you have any questions until then, or if you need anything, just drop me an email. Okay.
Thank you, bye, sir.
Sir,
All right. Yeah, Kareem.
I was doing a past paper and I asked for the operation of USB.
Yeah.
Do we need to know that?
No, stay online and I'll explain why. Munaim, in your year, emailed me. So I'm just doing it. Give me 5 minutes. Just doing a session. I'm online. Okay. So give me a second, please. I sent Munaim sent me this email, and I will show you the response that I sent him. All right. So let me present to you guys if you can see. All right. Can you see my email?
Yeah.
All right. So my name said, do we need to know the workings of input and output devices such as printers, all of these keyboards, and because there's loads in the past papers, right? But then if we look at the marks, the specification, look at this. I don't know if you can see it very well. The old specification, it said, describe the principles of operations of how these devices work. So like, scanners, USB, memory stick, keyboards, cameras. But the new spec, it doesn't say describe the principles of operation. It just says understand what is meant by an input device and why it's required. So you don't need, in the old spec, you'll see a lot of those detailed response questions, but in the new spec, all you need to know is what is meant by them, when you could use them, for example, and why it's required. Okay?
All right, thanks.
All right, okay. Any other questions, guys? All right, guys, all the best in that exam. And then we'll do another paper 2 session on Tuesday, next week, Tuesday, I think period 1, paper 2. So we'll do paper 2, and then the next day on maybe Wednesday, because the exam's on Thursday, we'll just do the 15-mark questions, which is the last question in paper 2. All right, guys, take care. See ya.
Okay, thank you, sir. Bye.
All right, bye.
Guys.